I see you, the guys who did not stand. Alright, I'm Siddharth, and that's kind of a lame introduction because how many Siddharths do we have in the room? Siddharth, Siddhants, all of that. Wow, right? And yeah, there's like so many of us. I think there are 2 Siddharths talking today itself, right? We can actually start our own conference, SidCon, right? And Hasgeek will sponsor it because we'll probably sell more tickets just to Siddharth than to the entire people, right? So this is how you can find me. I'm Siddharth KP on most of the social media platforms. I'm a JavaScript architect. You can talk to me about design, JavaScript, web performance, that kind of stuff. I do a bunch of open source, and I do this weekly thing where I record what I've learned and I put it on YouTube. You can find it on bit.ly/SiddharthKP show. Finally, I also teach React. You can go and look at bit.ly/React training if you're hoping to learn React. I co-organize React Bangalore, which for you means I have stickers, right? You can grab them outside after the talk, the same place you grabbed your t-shirts, or you can go down and there are also some other reception. If you don't find them, I have some more. Cool. Enough about me. Let's talk about the future. So this is a question that I've been asking for a while, and most of the industry is asking same. Is fiber ready yet? And it took a while, but then finally, this last month, the answer became yes, right? Fiber is ready. And we have an RC available as well. So what is fiber, right? Like, it's a fancy term. So fiber is basically a ground up rewrite of the diffing algorithm that React uses, right? The reconciler. It's the same diffing algorithm that React uses to figure out which parts of your DOM has changed and which parts haven't, so that it can nicely re-render your DOM, right? The optimization React offers. So they rewrote that. Good job, Facebook, right? But then what does it mean for us? So this talk is divided into 3 parts. The first one is what's new in fiber. The second one is why did they rewrite the reconciler? And the third one is, portals. Let's start with the first. Let me start by saying I really love React. It's changed it's changed the way I work. I really like it. But I have these 4 tiny complaints, right? I'm gonna talk about them one by one. The first one is very simple. I have to render something like this. I wanna render a h1 and I want to render a p tag right next to it. When I have to do this, I create a component. I wrap them in the return, right? Sounds all right, functional components. But when I do this, I get an error that adjacent JSX elements must be wrapped in an enclosing tag. This is really annoying, right? I just want to render this. Why do I have to wrap it? But fine, I suck it up. I render this in a div. It's slightly extra tags, but fine, I live with it. But then, if you want to render something like this, I have 2 table rows, and I want to render them adjacent to each other. I try to wrap them in a div, but then I get an error that table rows cannot be inside a div. That's just not allowed. That's semantically wrong. So I can't do that. Maybe I can wrap them in a T body, but then I can only do this once. I can't have 2 T bodies, right? Duplicate T bodies are not allowed. That's also a problem. And this has been kind of annoying for the longest while. You can use hacks and stuff, that's what I do. But then in React 16, what you can do is you can, instead of wrapping them, you can return an array, right? So you just wrap them in those array tags, put a comma, and then React renders these 2 adjacent to each other, right? Tiny annoyance fixed by React 16, awesome. Number 2, so when shit goes down on production, right, React kind of deals with it differently. So in development environment, it's really cool. It gives you this nice error. It also tells you the file name. You click on it, it opens in your editor. Excellent stuff by the React team. But on production, you just get a minified error, and then you click on it, it shows you the minified thing. You can't really make sense of it. The worst part, your users don't know what to do with it either. It's just broken UI, right? With React 16, they introduced a new lifecycle hook called component.catch, which gives you an error and an info as parameters. And you can use this to create error boundaries. Think of error boundaries as try catch, but for your components. So I have this buggy component that I'm rendering. I'm going to wrap it around an error boundary. And I'm going to show what this error boundary looks like. So it's a React component. That's where I start. It has a constructor where I say the initial state is that there is no error. So I say has error is false. Now when it renders and it fails to render its child component, component did catch file. Pretty nifty. And this is the place where I said error is true now. This is also a good opportunity to send error messages to your bug tracking system, right? Awesome. And then when I'm rendering, I can just check if there is an error, then render my error message. If there is no error, then render the children, right? It's like an error catching higher order component. Awesome. And you can show fancy things to your users instead of just breaking the UI and not telling the users at all. Awesome. Number 3, complaint number 3. So I use server-side rendering a lot, which means I also use renderToStream a lot, and I'm not a big fan of it, solely because renderToStream, first of all, is synchronous. Secondly, it takes a lot of time. So this is a benchmark done by Icon, and so he found out that in his performance benchmark on Node 6, React 15 takes around 82 milliseconds to render, right? And it's still cool if this was in the browser, but if it's on the server and it's synchronous, this really hurts how much you can scale your application, right? As in when you get more scale, requests are going to start queuing up because for 82 milliseconds, you're just trying to render the DOM. On React 16, however, they optimized it and now it takes only 28 milliseconds. It's 65% faster, right? Might not mean a lot for me, but my DevOps people are super excited about it, right? It means less servers, more scale, they spend less money. Complaint number 4, slightly related, which is when you use renderToStream, this is kind of how you use it. You get a request on your Node server, you say, all right, I'm gonna pass my app component to renderToStream. It's going to give me the HTML string, and then I'm just going to pass it along to the client, right? How many of you use renderToStream? Server-side rendering? All right, good to see so many people. Good job. But because this is synchronous, a user request comes, but you can't really say anything to the user until the whole render is completed, right? It's synchronous. However, what they've changed in React 16, you get an extra function which is renderToNodeStream, which means you can do the same thing. You get a request. Instead of renderToStream, you use renderToNodeStream, and that actually lets you stream the results. You pipe it down the wire. So which means as and when your components start rendering, you start pushing them out to the client, which means your header can come, then the next part comes, then the next part comes, right? Your users don't have to wait. It's good for SEO. Time to first byte is really small. Everyone's happy. So a fun fact about React 16 is that they test all of the releases of React on Facebook production as well. So if 2 billion people are using it on production, I guess we can use it as well, right? Like if Facebook uses it, it's safe enough to say that our users are much less than that. They'll be fine. So you can just npm install and chill. How you do this is you type npm install react at next and react DOM at next, which will give you the release candidate build for React 16. And if you're not into release candidates, if your DevOps people get scared, then it's all right. You can just start using it in development. Wait for like a couple of weeks when they get the stable version out. It's really new. If you run into any performance regressions, they already have an issue open for React 16 RC where you can just report. They've done a really good job and made sure that nothing will break. This is a backward compatible release, so you can just blindly upgrade and everything will work. If it doesn't, you know where to go and shout. All right, cool. So that's fiber. Now the second question: why did they have to rewrite the reconciler to be able to do this? And for this, I want to kind of show you an example. The reason they did this was better scheduling of work, and I'll come to that. What does that mean? Say you have a list of users, right? It's a bunch of happy faces, and then you have a filter on top. As a user, when I press a button, I type S, and the list filters, the input button repaints, shows me what's going on. I type again, it does the same thing again, and again, very boring. And yeah, this is how it renders, right? But then, if you have a long list of things, things are not as happy. When you start typing, and you're trying to filter a long list, when you type, the list takes a while to re-render, and you're typing, by the way, but things don't come. Things come suddenly, right? So you might have seen this. When you're typing, letters don't come as you type, but they come all of a sudden, right? Anyone who works with UI who are janky, who are laggy, and seen things like this, you're typing, but they come like abruptly, yeah? Yeah, you guys have seen the, whoa, most of you have seen the pain, wow, right? A similar use case is when you're scrolling, but the things are not rendering. Your scroll is stuck, and then suddenly it scrolls all together, right? All of these reasons are the same, janky UI. So let's kind of dig in on how this works and try to understand what's causing this lag. So you have a human layer, which is like the keyboard typer. you have a JavaScript main thread, and then finally you have the DOM where things repaint. Now, as the user types in S, there's an input event that fires, like a key down. Based on the key down, it gets passed to the DOM, and the DOM repaints. Simple enough. You do that again, there's another event. Instantly after the JavaScript event, the DOM repaints. Cool? This happens when you type, as fast as you type. But when you're working with a long list, this keyboard event, it's not the only thing that the browser or the JavaScript thread has to do. It also has to render this long list of things that you have, right? And if it's a long list, filtering it and re-rendering it might take some time. And as you can guess, what's gonna happen to your next input event? It's gonna get queued after that. JavaScript is synchronous, right? So now what happens is, even though you're typing, your things are getting queued, and they will only repaint when this long, big, fat render finishes, right? And this is kind of what happens in the big UI that I showed you. You type at a normal speed, but it doesn't render as fast because your input events are split by long-running render functions, which is pretty bad, and it leads to this janky UI where things come all of a sudden. So, right, this is a problem, but how can we fix the problem? That's what we're here for. So think about it. What if you could split this long chain of work, right, this big fat block, into smaller pieces, right? And depending on what is more important, like I'm gonna flag user events because those are more important to me, and then I prioritize them and schedule them, right? So I start by rendering user events, a render starts, I block it, right? Another user event comes which is more important, I prioritize that, and I carry off my rendering after that. Make sense? Prioritize user events, that's more important. Delay, deprioritize render events, right? How do you do this? This is kind of tricky, right? How do you split render blocks? So an interesting thing that I want you to notice is that this UI of ours is actually made up of a lot of tiny components, right? In React, we're already using components. All of these are tiny avatar components which get reused, right? Which means you already have the tiniest amount of rendering that you can do. So that's what React 16 does. It splits work on component boundaries. So it can actually start rendering components, stop whenever there's a user input, and then carry off where you left it, right? Interesting. So they call this concept cooperative multitasking, which is like a really, really fancy name, right? But it makes sense. And so if you want to read more about how Fiber works, how this async rendering works, Andrew Clark wrote a nice article on it. You can find it on his GitHub. If you're not into reading that much, Lynn Clark in the recent React Conf at London, I think, talked about, she gave a cartoon intro to Fiber, which is how I learned Fiber. That's my kind of thing, right? So you can go watch that. Just search on YouTube for Lynn Clark. All right. So let me now tell you what's in the future, right? This is all done, right? This is all we have. But React 16, the RC candidate that we have now, doesn't have async rendering enabled by default, right? But when has that stopped us? So what you can do is open your node modules folder, go to React DOM / the development file of React DOM. You'll see this flag which says Fiber async scheduling false. Toggle it to true. Suddenly you have Fiber, right? You have async rendering. And then when you set state a big fat user list, you can wrap it into React DOM.unstable deferred updates, which will make this low priority, which means it will break it down into tinier tasks, and when a high priority task comes, it will just squeeze it in between, right? Awesome, that's the solution. This will become stable in the following releases of React 16 that come along. Cool. Number 3, which is the thing that I'm most excited about, to be honest. Yeah, it's called portals, all right? And this again is something that will come in the future in React, but we can start using it today. Portals is something interesting. Let me start this way. So if you've used React DOM.render, which I hope everyone has because it's a React conference, what you do is you render the root component, your application component, and you give it a target. This target is the root of your application. It's the parent-most div tag, and you render it, right? With portals, what you can do is say React DOM.createPortal, take another component, like whichever component you want, and give it whichever target you want. Think about it. So you can render any component from inside any other component that you want, right? So usually when you render in React, you're only rendering children, right? You start at the top tree, you keep going in children. This way, you can actually start anywhere and render something outside the tree. right? Or interrupt any other tree part out of the blue, right? So this of course sounds slightly scary, it's slightly icky, but we'll talk about the kind of opportunities that it opens up by talking about some real world problems. So this is one problem that I have. Let's take the example of this famous food delivery website called Tomato. And how this works is they care about SEO, they care about server rendering. So they render all of this on the server, good for them. And then how they do this is they basically on the server they say react dom.renderToStream, give it the entire component and send this down the wire by wrapping it in a div-id route to identify. When this thing comes on the browser and the browser bundle arrives, they hydrate it by saying react dom.hydrate and give the same application and give the same route, right? So it's like saying on the server render a static version of my application, and then on the browser, you can't see colors. On the browser, activate it when the JavaScript comes, right? By activation, I mean attach event listeners, attach set state handlers, all of those things so that it's actually interactive. And this is a pretty good approach. The only problem with this approach is that until your JavaScript bundle arrives, the user can see the UI, but he can't click it because, hey, JavaScript is not here. Interactivity doesn't work, which is pretty terrible. Depending on how big your file size is, this uncanny valley becomes longer and longer. So the trick here is make your file sizes smaller, right? Let's think about how can we do that. So these are the components that I have on the server. Right? I've broken down everything into tinier components. This is what I render from the server and ship. These are the components on the client that I ship. So it's basically the same thing. I take everything, all the components, and I ship them to the browser, right? That's how React Hydrate works. But the interesting part in this UI is that only these two parts of the UI are dynamic. Rest of it is just static. Once I've rendered it from the server, it doesn't change. So why am I shipping all of this extra JavaScript? This really annoys me. And I tried solving it. So what I did, I identified the components that I need on the client, only those, and instead of rendering an entire app on the browser, I changed that to client. And then in my client class, I only have the components that are required for the client. Make sense? Why should I ship everything else? And I did this, I rehydrated on the same element, right? Who thinks this is stupid and I'm gonna burn in like fire? No one? Interesting, because unfortunately I am. So how this works is, I render from the server, everything looks tip-top, right? HTML is there. When I rehydrate it, React essentially replaces everything by only the things that I gave it, only the components that I said use on the client, right? And this is kind of obvious in retrospect. I basically said, hey, render all this on the server. When you reach the client, render these things only, right? So React says, okay, that's what you want me to do. I'm gonna delete everything else because apparently it's not important for you. And yeah, so that's what it did. And yeah, so this was a fail. So then I started thinking, why do I have to hydrate? Right? I already have this on the server. Do I really need to hydrate everything? Can I not create a parallel client tree? That's what I started with. I created a different route for my clients. I create a client route. And then instead of rendering the client on the root element, I say render it on the client root element. Right? And now the problem with this is that I have two trees that don't talk to each other, right? There is the React rendered tree from the server, and then because I haven't hydrated it, anything that changes here doesn't really update anything because no JavaScript. And the other tree that I've created on the client just sits right next to it. And I end up with having two copies of the same thing, right? But what I can do differently on the client is this. I can use portals. So I'll show you how. My client basically looks like this. It's a React component, of course. In the constructor, I say, remember that cart element that I rendered from the server? We're taking over. Grab that by the element and flush it, like just empty it, right? I'm setting inner HTML as blank. Like this component is mine now. And React DOM can't really stop me because I didn't hydrate it on the browser, right? I only sent it on the server. There's no one to stop me. So I go and say my component. And then in my render function, I grab that cart element again and I re-render the cart element fresh by creating a portal. So this is the real power of portal. You can render a component wherever you want, right? I can just say, remember that cart element that was rendered in a different tree, grab that and render my component over there. Like screw that, render what I want, right? So I'm taking control of render on the browser. And let's see how this works, right? Might be a little confusing. So this is what comes from the server, looks pretty, very nice. When my client bundle loads, I overtake the client, I overtake the cart, I delete whatever is there, and I re-render a fresh copy of the cart. And if what you're rendering is small enough, the users can't even perceive this. It happens like this. You get on the server, client comes, it flushes it out, and now you control this cart, right? So the good part is, now I only ship what is required on the client. I don't ship the rest of the static stuff. I also need the menu here, so let me render that as well. What I do in my constructor, I say, remember that menu component? Mine. I flush it out, and in my render function, I say, grab it again and create menu, create a portal into that, and render my menu component, taking over. So same thing happens, render on the server. When the client bundle arrives, remove what is rendered, remove these two components, render my fresh new component, which I control now, right? So now how many of you think this is a bad idea and I'm gonna burn with fire? Ah, nice, I see some hands, awesome. So it is kind of a tricky idea because you are going around React DOM to render your own stuff, but the good part is that I get much better perf. I don't have to ship everything to the client, I only ship what is required, and then I don't really work against React DOM. I pass this to React DOM and say, hey, these two components, create a portal, you own them now, alright? So essentially, instead of using the default hydrate, I'm using portals to make my own hydration. Cool? Alright, yay, performance. Real world problem number 2. So, let's take the example of this, right? I have the same menu. When I click add, I want to change the counter, right? When I order 2 margarita pizzas, I want the counter to change. And how I usually go about this is I create a state in my menu. So there's menu.js, which has an initial state where the count is 0 for both the items. When you click 1, I fire an onClick. It's a function handler. And then I change the state and I say, hey, change the count to 1. And that renders back. Yeah, everyone cool with this? This is what you do. When I order a margarita pizza, again, it changes the count to 2. It renders down, right? This is how stateful components work. Now I have a cart. I want to show the cart as well. When I add something, I add Zen Pizza, which is like the fanciest name I've heard, it's Zen Pizza. When I add the Zen Pizza, I also wanted to show in the cart, right? And when I remove it, the cart should also refresh. So how I usually, or how most people do it, is they abstract the state onto a common parent of the menu and the cart, which means I usually put it in the app, the root level, the state is here. And this is like a pretty common approach that you send state down as props, and then you send request to change the state as prop functions. So the props now have the actual data. They also have functions that you can call to change the state upwards. Let's see how this works. State is upward, I pass the props. Now menu can render what is there in the state. I also have an onClick on the app component at the root, which I pass as a prop. It's a prop function. And then when you say plus, I call this function and say, hey parent, somebody click plus, please change your state. So when the parents state changes, now any other children can also get these results, which means I can pass it again as props to the cart element. Fair enough? Pull the state up, pass functions for updates. When something updates, pass it back to the parent, all the other children get it, right? This is what we usually do. Some people don't like this, they feel, functions going down, coming up, icky, right? This is why people use Redux. Sure, do it. Redux is awesome. So how Redux works in this case is that the state of the application sits outside the application in something they call store, and then you can have React components that are subscribed to the store, right? You do this by using connect from React Redux, which means that whenever the state changes, Redux will inform these components that something has changed, right? And when you click plus, when some action happens, you dispatch an event to tell the store that, hey, somebody clicked add item, first one or second one, Zen Pizza. Somebody clicked plus on Zen Pizza. The store says, thank you for telling me. I'm going to update myself. And then all the connected items or the connected components get a message that, hey, this has updated. Alright? This is like the pub sub model that is famous for, I don't know, like 100 years on backend. But then when we got this on front end, we're like, right, losing our shit. So cool, very nice approach. But then there are problems with Redux, right? People say, oh, I have to write a reducer, I have to write these dispatch, right? What is dispatch? Where is the store? There's a lot of boilerplate. I really like this tweet because it's Dan Abramov, the co-creator of Redux, who says, you might not need it, right? If you have a complex use case, Redux is awesome. But if you have simple use cases like I do in life, like my cart example, you probably don't need it, right? It's not worth the extra pain. And you can of course go back to what I suggested earlier, passed on props, pull up function, or you can do this. So I'm back to the state in my menu function. When you click plus, not only do I fire the state of this component, I create a portal. And some of you might see where this is going. I create a portal and I say, remember that cart? My cart, right? I'm gonna take over the cart. Let's see what the code looks like. You have your menu, and you have constructor, on click, all of that with set state. Inside the render function, what I do is I say, give me the cart, flush it, my cart, I'm taking over. And then inside the return, I say react dom.unstable create portal, and then I render the cart again, this time with the state of this component. So I'm saying the state in the menu, that is where I'll maintain my state, and then when I need to show it in the cart, I'll just pass this as props. Right? I don't have to go up and down through the parent. I don't have to get a reducer involved. I can just say my cart. I'm going to render it however I like, right? So this is an interesting approach. It might not be the best approach. It's slightly tricky because you're kind of taking over and saying, React, you do your thing, I'm going to do my thing, right? And React DOM totally supports it, which is good. You don't really end up in checksum errors because of this, because you're using React DOM to do it. React DOM understands, okay, fine, you want control. Here's the control. Create a portal. I'm gonna be happy with it. I'm gonna look from far and clap. So this is how it works. I have the menu. When I click plus, I take over the order and render a new cart, pass state as props. Make sense? How many of you are cool with this? Understand? Okay. How many of you hate this and will beat me up outside? How many of you, please keep your hands raised. How many of you guys use Redux? No, I'm sorry, like, put your hands down. How many of you are gonna beat me up outside? Keep your hands up, right? How many of you, these guys who have their hands up, use Redux? Aha, that makes sense. Almost all of you, right? Yeah, so cool. If you use Redux and you're happy with it, if you're happy with the extra weight, if you're happy with the extra code, the extra immutability that it lets you use, awesome, good for you, I'm happy. For the people, rest of you who don't use Redux, just create a portal, move on with your life, you have better things to do. Alright? Yay, state management, without adding an extra library, or a lot of code, right? Sorry, this is like a very sad punchline, but yay. Alright, so I use this, and some of you might be looking at and frowning at the unstable underscore, right? And this happened, I used this at work and people got mad. So I asked around that I really like portals, but I used unstable and people got mad. And Sophie Alpert, who's in the React core team, actually replied, they use it on production. So Facebook uses unstable portals on production. Same again, the API might change a little, that's alright. But if it works for them, 2 billion users, they've already tested it for you. You don't really have to worry. You can use it too. Cool. So we talked about these 3 things. I hope you liked it. I'm Siddharth KP. My DM is open on Twitter. Say hi. If some of this went over your head, pay me, I can teach you. Right? I do bit.ly/React training. That's all. If you have questions, we have 10 minutes to answer questions. Awesome. Also, if you ask a question, you get a sticker. So many answers. Yeah. Oh, sorry, we're not allowed to distribute swag as part of the talk, so you can grab it outside. Way to kill my buzz.
Yeah, hi. So when you were telling about flushing it out and then again passing it using the portal, so you're basically unmounting and mounting it again, or like the component did update will be called, or only the component will receive props? So
sure, depends on which example you're talking about. If you're talking about the first example,
no, I'm talking about last example.
Sure, about the state.
Cart and
right. So the interesting part is that none of those life cycle functions would be called because you're not really going through React DOM, right? You're basically saying that component that you rendered React, screw it, it's my component. I own this component. And then when you call a portal, then all the lifecycle hooks go all over again. So you'll get component will mount, render, component did mount, right? It's not an update. It's like throw away that, render again, new one.
So don't you think performance issues will be there? For example, if you have a data visualization there and you just click some filter here and you want to make it movable. So like on the mount, like if you are using some high charts library or something, then it takes time to get attached. But if you're just doing like if you are just passing and having the component will receive props, then it will be fast, at least for this data visualization example.
Sure, yeah, so that's a pretty good question. This has one con that you lose out on did component update and component will receive props, like optimizations that you can write. The interesting part here is that all of that code doesn't really fire in this case, right? You directly render. So the render that would have been called anyways would be called again. So that's the same performance. But if you were applying performance optimizations yourself with on lifecycle hooks like component did receive props, you can't do that. There is a tiny hit there. Maybe don't use it for visualization, but yeah, use it for everything else. Sure. So the question is that if you take over the DOM and you flush it and re-render it again, wouldn't there be an effect? Would people see the gap? So the pure answer to this is yes, there will be, because you just deleted something. But the practical answer to this is, if your component is not too big, like my card and most of my page, right, the user wouldn't notice, right? So it's as fast as React DOM render, which means it's like milliseconds, 2-3 milliseconds, which means your eyes cannot perceive it, right? So as you said, if you're using visualizations library with a huge render, maybe the user will notice. But if you're for anything else, for the rest of the room, nah, use it. It's super performant.
Yeah, hey. So something about the same, right?
Yeah.
What if I don't flush it out? Will portal still work, or what will happen then?
Sure.
Because I have a problem with flushing it out, right? Because when you do inner HTML equal to like empty string,
yeah,
it's basically gonna take away all my events that have been attached,
yes,
either by me or by any other library.
Yes.
So that's gonna lead to a lot of problems.
Sure. So the interesting part here is that I'll first address the second part of the question, which is all of the event handlers will go away, which is true. You're basically deleting everything and saying, delete whatever you have, I'm gonna put my stuff all over again, right? So you do lose the event handlers. When this renders again, those event handlers get attached again, right? So you don't lose stuff, you just redo them, right? Think of it as unmounting and then mounting again. That's all it is, right? To answer your first question, that what will happen if you don't flush it is you'll just get 2 copies of it. So the first one is there, and React DOM and create a portal also over there, and you get 2 of them, right? So if you want to solve the flickery problem, or if you're touchy about deleting stuff, you can just set state and hide this, right? So then it's more live reload. You can have one which is there, you can render another below it, and then flush this out. Or maybe use indexes. You have one, render one in front of it, get rid of the previous one. Yeah. But then yeah, lifecycle hooks get reattached again. There's no worry around that.
Hi, here.
Hi.
I have one question around like one concern actually.
Sure.
Because maybe I am looking at it for the first time.
Yeah.
We as UI developers and even on the backend side, we have always been concerned about the flow of data, the flow of information, right? And we always have faced problems with spaghetti interactions. And that's why we have got so many structures, so many data patterns, even like MVVM plus all these things. It came up to solve that issue.
Sure.
In this one, I see sibling components talking to each other directly. This was a simple example, but when we take it to a more complex real-world application, will it not be more like what will happen to maintenance of the code?
Sure. So it's a double-edged sword. That the moment you say I want more control, right? You are saying that I am responsible for the mess that I create, right? So of course, if you write bad code, you'll end up having bad code. But if you do it right, you'll get it right. That's like a fake answer. The more practical answer over here is that you don't really have to do this all across your app, right? I'm not saying get rid of state management or get rid of global store. What I'm saying is the places that you have to pass them a lot of props down, a lot of trees down, and there is only one way that the data flows. For in this case, data doesn't flow from all the direction. Data flows from menu to sidebar, right? So it's essentially saying that menu is not only responsible for its own rendering, which is a child render, but it's also responsible for its sibling rendering, right? So, and to be honest, this is not a new concept. React portals, not natively, but outside of React in the user land like libraries, has been around for a lot of time. And the most popular example is pop-ups. So when you have to build a pop-up, it's kind of all over your UI, right? It's an overlay. It's not really a child. So when you render it, it's not really a child of anyone. It's kind of a different tree altogether. People use portals for exactly the same thing and have been doing it. This is where it kind of found its original use case, that people want to render something out of the tree, and this is how it got introduced into native support for React. So, I mean, yeah, we're kind of used to rendering children, but if you think you can simplify your code, that's the key. If you think you can simplify your complex logic by rendering a sibling directly, then that's better architecture for you. That's better code, better maintenance. Hi.
I really like your idea. It's kind of out of box.
Thanks.
I just had one question. The whole idea behind React is to abstract away the DOM, and and then they made this tool called Virtual DOM for it. Aren't you short-circuiting that to use this API? I mean, what do you think about the principles? Just talking about the idea.
I want to say almost, right? So what I'm doing is I'm saying I'm still using React DOM and saying the one that you had earlier, forget about it, take a new one, right? This is your new friend now. So the manipulations, like React still owns the DOM. I don't really own it. The only thing where I have to do, where I own the DOM or I'm manipulating DOM myself, is where I say inner HTML is blank, right? If you don't like it, then you can also use set state and just hide this component, right? So that React controls all of it. But to be honest, we're saying, React, you had this, forget about it, now you have a new one. The rest of things is still React. We just kind of say, we are like a portal from one component to the other, right? That's where the name comes from. Hey, Sid.
So Sid,
Thank you.
so my question is on lifecycle methods.
Yeah.
You say that create portal directly jumps into render. So that's what you said, right? It directly jumps into render. It doesn't call the component did mount and component.
Oh, it totally does. When I was talking about that, I was referring to the original component that you had. That might have some optimizations of component did catch or like component will receive props.
Correct.
All of those guys wouldn't work anymore because you threw it away and rendered a new one.
Correct.
But this is like the whole render lifecycle of a new component. It's going to go through will mount, render, did mount. All of that still works. It's still React.
So would you suggest that it's better maintaining the lifecycle methods in the parent component, because anyway it's rendering, so we can automatically optimize it for all the optimizations in the parent component instead of maintaining the portal component, the one that you create with create portal.
So I think instead of using portals, can I do the same job by using the same in the parent? Yeah, you can. The first example that I showed you, where the parent kind of takes care of the state and passes it down to all the children. That's the way we do it now, right? That totally works. I mean, that is the standard React way to do it. You're saying you will create a portal, but then instead of rendering a complete component which is responsible for its own life cycle, the parent will take care of it. Yeah, that totally makes sense. I think it's a better idea than what I suggested, because your parent is anyways taking care of the state of the child, right? It passes what it wants in the render, so might as well take care of the life cycle also. Yeah, that's a pretty good idea. Thanks.
Sounds like this could be a really great offline discussion later on. Sid, thank you very much.
People who wanted to beat me up, I'll meet you on that side. For the rest of you, I'm over here. Thank you.
Thank you, Sid.